When you're writing balanced equations, sometimes you need to show the phase of the matter behind the substance. So S is for solid, L is for liquid, G is for gas. There's debate about whether it needs to be a subscript or not. More and more now people are just writing it behind as on the normal line. Aqueous means it's been dissolved in water, and you just put AQ. So for example, you could say NaCl AQ. What does that really mean? It means that the ionic compound, sodium chloride, has broken up into its Na plus ions and Cl minus ions in water. Relative atomic mass. Relative atomic mass is the ratio of the average mass per atom of the naturally occurring form of the element. In other words, we're taking all of the different naturally occurring forms with all of the isotopes, and we are comparing it to 1/12 of the mass of a carbon-12 atom. So a carbon-12 atom has got 6 protons, 6 neutrons, and 6 electrons. But as you can see, if you get an accurate periodic table, carbon actually has a relative atomic mass of 12,011, which is because there's also something called carbon-13 and something called carbon-14. They occur in very small proportions, but they do change this number a little bit. Iron is Fe, and it's got 26 protons, and as you can see, it doesn't have a fixed number of electrons. It's at least electrons of neutrons. It's got approximately 30-ish, but 29, 28 neutrons, depends on the exact isotope of iron. But as you can see, that is not a whole number. It has taken into account all of the different isotopes and average them out. How would we do something like that? If you take a look at the whole periodic table, you're going to use these relative atomic masses that are given over there. And if we were to say what are the differences between chlorine 35 and chlorine 37, and what are the similarities? Well, they've got exactly the same number of protons, but they have a different number of neutrons. This chlorine's got 20 neutrons, this one has only got 18 neutrons. And you would, if you need to calculate the relative atomic masses, which is not really in the curriculum, but there is, if you look in the revision folder, there is a reminder of how to actually calculate those relative atomic masses. Explain why the relative atomic mass of hydrogen is not a whole number. It is because there are 3 different isotopes of hydrogen. There's hydrogen 1, which is called protium, hydrogen 2, which is called deuterium, hydrogen 3, which is called tritium, and when you take an average of all of those atomic masses, you find that you get 1,00 something. I think it's 1,008. What is molar mass? Now, the molar mass is the mass of grams of 1 mole of that substance, but we kind of need to know what 1 mole is. Now, we'll go into a mole in a bit more detail, but basically it's a number of atoms, the same as you would say there are a dozen rolls, and you really mean there are 12 rolls. If you say that there's a mole of atoms, you really mean that there's 6,02 times 10 to the 23 atoms. And we'll go into that in a little bit more detail, but it's a pretty big number. So it's turns out to be about that many atoms, which is quite a lot. And it's because atoms are really small that we work with quite a lot of them bunched up together, because we can't really tell you very much about one single atom. Anyway, you're going to use the periodic table to decide what is the molar mass or relative formula mass of a certain substance. So if I take a look at the molar mass of individual substances, this is the sort of thing that's going to happen. The molar mass, for example, of sodium is 23. The molar mass of sulfur is 32. The molar mass of technetium is 99. The molar mass of helium is 4. But what about if I've got a formula such as potassium permanganate? So I'm going to say, firstly I need to know what potassium permanganate is, and potassium has a valency of 1 because it's in group 1. There it is. And MnO4 minus has a valency of 1. Hold hands. So the formula for potassium permanganate is KMnO4. If I want to know its formula mass, then I'm going to say, what is potassium over there? And I find that it's 39. So it's 39 plus whatever manganese is. And manganese is 55. And oxygen, there are 4 of them, and they are 16 each. So I add those all up, and I land up with 158. That is known as the molar mass or the relative formula mass of potassium permanganate. You can go through these. You need to try and do them on your own. Press pause and then come back to watching how I do them. Hopefully you've worked through them now. Now you can take a look at the answers. So it's going to be 23 plus 23 plus 32 plus 4 times 16, and that's going to land up being 142. Nitrogen is 14 plus 4 times hydrogen at 1 plus another nitrogen plus 3 times oxygen, and oxygen is 16. You get 80. Iron is going to be 56. There are 2 of them, plus 3 times oxygen at 16, and you get to 160. Magnesium is going to be 24,3 and plus 2 times 16 plus 1, and maybe we might have left out that 24,3, maybe we were just on 24, and you land up at 58. You do need to use what's on there, so I think 58,3 would have been a better answer. Then you are going to go to calcium, and calcium's 40, plus 2 times hydrogen at 1, sulfur at 32, 4 times 16 for oxygen, and that's all times 2, and you get 234. The last one's a little bit tricky or a little bit different. This dot over here is not a multiplication. These are known as waters of hydration. These waters get trapped in the crystal lattice as the ionic bonds form, and there will be 7 waters added onto each magnesium sulfate. So you need to add them in, and therefore it is going to be magnesium at 24,3 plus 32 plus 4 times 16 plus 7 times 2 times 1 plus 16, and when I add those all up, I get 246.